Now, we prepared a similar table as we did before for the other polynomial, and we sort of figure out the min and max. And then the next step is, of course, as we did before, put all the points on a plane and figure out how to connect them. The next, what you will see that is missing is -2 and -64 is not here. I'm more interested on the behavior around the x-axis, and therefore I'm just using this to make sure that the end behavior is happening as I was expecting it to happen. And then again, another one is the 3 and 16 down here is not shown in here. The only thing that is -2 and -64 is telling me is that this end behavior is toward the negative infinity, and the other side end behavior is by 3 and it goes to positive infinity. Now, the first step I want to do, let's hold it for a minute. X plus 1 equal to 0 would give me the x-intercept -1. That's this point right here. So it's important for me to actually make sure that I'm following the rules of multiplicity of the zero. And the multiplicity of 0 here is 2. That's an even number. So what I know is that I'm going to go smoothly toward that, and then oh, this was not as smooth as I wanted, but then I'll go down like this. Smooth it out a little bit more. That is, it may take a few tries to make it, and so erase the extra parts and it will work well. So for example, I'm gonna erase some of the extra parts and make it as smooth as possible. It will be better when you're using pen, of course, and I'm not using one right now. And so in my case, I'll try to make it as smooth as possible and that sort of thing. So I took care of a multiplicity 2 here. Then I have to take care of a multiplicity 3, which is 2 and 0. 2 and 0, we have a multiplicity 3. That's an even one, so it's going to pass through it. So when I'm going, I have to make sure that I'm somewhat nicely going there and then going back up, and I know I'm going. See, I made that little curve that is supposed to happen. Then we're going to connect them all together in a smooth sort of way, and I know the minimum is achieved somewhere between those 2 points, and it goes like that. So the better one, if you have a if you have a thin pencil, you can draw a nicer one that looks like this, and it follows all the rules that we discussed. So how do we graph the same function plus 10 as just moving it up 10 units? Something that I want to mention is that, so we learned a lot about graphing function this time. Most of the examples that we saw, they were all factored already and given to us, or there were a obvious parenting function that was factored, and we could use to be able to just take any polynomial that looks like what we're used to see, like the very first example of this lesson. it looked like a polynomial. It didn't look like a factor form. To be able to do that easily with any kind of polynomial, we need a little bit of calculus in there. Calculus helps us find the relative minimum, relative maximum, concavity. Concavity is how everything curves and that sort of things. And then the end behavior becomes a limit at that point, and we really discuss it in calculus, and that the first term actually gives us how, and the coefficient of the first term gives us how the end behavior is doing. So that's it for this lesson, and do the quiz, please.